Ah, should be live, probably. So just waiting for the test. Courtesy to you. Yes, and it's a courtesy. Probably. So just wait. Yeah. All right. So I didn't get the first little tiny bit of what I said. Um. So it's a what a tragedy. Probably not. Um. All right. So, yeah, I thought I'd read this comment. Ended up in the spam folder. Big long pile of crap. Um, and just the usual. Somehow I'm supposed to be convinced that what I have observed and figured out, um, pieced together, whatever, um, is somehow wrong because this person, I don't know, says this stuff or something. I mean, it's just not a convincing argument. So you're through in Mendham. Well, I'm not. The game is over. No, the game is never over. Um, I'm going to be proven right. So I'm really confident about that. So you're not diminishing my confidence by just saying you're a naysayer and a nitpicker and you say no. That's not going to convince me. So nobody wants to sit down and discuss your theory. Well, that's nobody. That's everybody's prerogative. Obviously, most people can't discuss it because they don't have enough knowledge to do so. And I would argue that even many physicists don't even have knowledge of the foundations of their physics. They can't get the history right. Um, if I asked one of them to explain exactly what Young discovered in the context of Newton's rings being already discovered 150 years earlier, I don't think they can answer the question. I don't think they understand the history. The only people who will discuss it are trolls like you and your pathetic sycophanic fan base, which again doesn't really show up here very much. So that's sort of a bogus and bullshit argument to make. Um, you already know about the lensing images. I already know what about them. I know that they don't work, that mathematically they can't make any sense. The lens is the wrong shape. It won't focus the light right for the objects at a distance. Can't see something far away. You can only see something close up with that lens. So if they are lensed galaxies, they'd have to be galaxies that were just a few feet away. you know, um, and that's not what they argue clearly. Those are just facts. So you want to explain how a lens shaped the wrong way can focus light? Go ahead and explain it. Draw me a picture of how the lens, the object is here and has a certain configuration, and the light comes from one side and the light comes from the other side. And no matter how you make the light come to the lens, now inside the lens, it can bend the right way where you can see an image that would have little stars in it, little dots representing a galaxy. Explain it. But you don't do that. You just say they must be right because they told me they're right. Oh, um, so you can't explain them. It's not my job to explain them. It's my job to point out how their explanation doesn't work, doesn't fit mathematically. Now, I've pointed out how the Eddington experiment hasn't been repeated. Now, they had ideal circumstances at the 100th anniversary of Einstein's creation. And even then, with a perfect eclipse over the most technically functional part of the Earth, they couldn't repeat the experiment. I mean, right there's a piece of glaring evidence. Um, let's see. You can't explain them without resorting to supernovas. Well, it wasn't a supernova, obviously. I was arguing with something much bigger than that. The fact that there are supernovas is just evidence that some things blow up sometimes in the galaxy, and that some things could blow up bigger things. And when a bigger thing blows up, it could blow pieces of a galaxy to some other location that seems theoretically possible. That's the extent of me providing an explanation. Again, it's not my obligation to explain, computer processed images, and regardless, They're the ones that have an explanation that doesn't work. It mathematically doesn't work. It mechanically doesn't work. You can't draw the picture of the photons and how they get to the Earthling's eye. So until you draw me that picture, there is no conversation. You're just saying it's true, even though you don't have evidence that it's true, or reasoning defending it's being true. And you can't make that reasonable argument about why it's true, that a lens shaped the wrong way can work. Anyway, that somehow blast particles with enough power to move galaxies. Yes, I mean they already speculate that there's these early, quasar type form of galaxies that actually have jets shooting out of them of very high intensity amounts of energy. So that's sort of something they already accept as existing. So I'm not inventing any new energy sources, retard. But somehow these same particles don't melt everything in their path. Well, there wouldn't be anything in their path. Part of what you're forgetting is that space is a lot of empty space. And when you see a flat image, it has all these layers in it. Some things are really close, some things are really far away, and it's all in one flat image. So yeah, the thing that exploded, there wasn't anything else in the way. It exploded in an area of empty space. And the images are all just layered on top of each other, like a transparency. You don't understand that that's how it works, that the stuff that's 15 billion years old is on the same level as the stuff that's only a light year away. That's all in the same image. Retard. Okay. You know that interferometers don't diffract the light. So somehow I know they don't, when I just pointed out how, of course, that's how they have to function. That it's really just a matter of the internal reflections in the glass that are creating the pattern. It's the double slit experiment, essentially. The single slit experiment, however you want to look at it. It's a small opening experiment. And that's what's creating the Newton's rings, Newton style rings. No interference required, just dirt on a piece of glass. Let's see, you've had this proven to you. No, there's no proof, so this is just a gross lie. There's no, where's your proof? Why didn't you post the link to the proof? Where's your proof? There's no proof. You haven't proven that dirt on glass doesn't create exactly the same pattern. Because it does. It's just a physical fact. It's a physical fact. And you're just playing this denial game. I've proven it on my own porch. Demonstrated. It's a fact. That's what it does. Just dirt on the surface of the glass. That's exactly what it does, is create the exact pattern. All right, to you. So there's no proof provided. It was pointed out how the glue is transparent. So again, this idea that the word transparent could mean something in this context of diffraction, when we're only talking about a percentage of the light that gets diffracted and a percentage that doesn't. But clearly, the slits are transparent, but the light's getting diffracted. Are you going to deny that the light that comes out of the single slit is diffracted? It's transparent, right? Between the slits, right? Small, narrow opening, Newton's rings, right? Small opening. Transparent. No one would argue that hole in the camera isn't transparent. But apparently transparent isn't the subject, retard. Yeah, you don't understand the subject. How our brain creates images is a different subject than what actually is hitting us. All right, if the special glue they use diffracts light, then so would glass. So glue is the same as glass, when we understand too that depending on how you make glass, you can make glass that doesn't have a consistent transparency, that does diffract light or diffuse light in kind of bizarre ways. So that's also a fact. You're in absolute denial about these facts. So again, there's no denial about the facts. Again, where have I denied that the aperture on a camera is transparent? Doesn't change the fact that the light is diffracted. It's a fact. All right. And especially when you're talking about little tiny bits of stuff, tiny bits. And so it's just a matter of us being able to perceive it. So if you magnified the images coming out of it enough, maybe you'd see the rings. So it's all about magnifying. If you cover the slit in the double slit experiment, here we go, then there is light where there is no light before. So where's your proof? Where have you done that experiment? Where can you link to that experiment being done? Because the problem is you can't just cover a slit. It just doesn't work that way, because it's just another material object you're moving into the slit, into the environment. They're very small to do the experiment right. And you can't just move matter around and say, there, I didn't change anything. Because, of course, that changes things. But just keep pretending. You cannot explain that without. So and I don't need to explain it, because you haven't demonstrated that it even happens. The fact is that when you change one slit, you're changing the other slit, in the sense that you're just like it's an electric charge. If I had an electric charge and I start moving the poles around, if I have 10,000 volts here and a neutral in between, and I start moving the neutral around, yeah, clearly I'm going to change the voltage. That's just a fact, idiot. Charge plates. All right. You can explain that without a wave particles of photons. So again, what's a wave property? So what does that mean? That the photons interact with each other, or that a single photon interacts with itself? So back to your interferometer experiment. Where have you ever demonstrated that single photons shot into an interferometer create the same pattern? Have you ever demonstrated it? It's just as doable as any other experiment, so why don't they do it? Well, that's right, because the results are going to be not to their liking. Faster than light communication. B, faster than light communication. Why would anybody even consider faster than light communication in this circumstance? How would that change the pattern at all? So that doesn't make any sense at all. Covering one slit requires faster than light communication? No, it doesn't. You're an idiot. You are in absolute denial about these basic rudimentary facts. So again, these aren't the facts. The fact of the experiment is that the math doesn't predict the correct pattern. The pattern isn't a smooth gradation in photons from light to dark, light to dark, light to dark. The pattern is different. And that clearly the only thing in the math is an angle. There's no interference or wave in the math at all. There's just an angle, sine theta. And all that angle is doing is being multiplied. So all you do is say the first bar is 0, and the second bar is 1, and 2, and 3, and you just multiply that times your angle. And that tells you where on the screen you'll find your bar. That's all. There's just an angle. No wave. That's a rudimentary fact. Okay. Likewise, you cannot explain the result of the quantum erasure experiment. I've already been over it. I've talked about it dozens of times. Polarization is not that complicated. The polarizing filters change the polarization of the light that goes through them by, say, 12%. So if light is this way and it gets through the filter, because it's only 12% off, it will be converted into this. It will be repolarized more directly. So it'll be changed by 12 degrees. And that's all you need when you have the 3 filters put in a row. You just keep changing the amount of off that off is. And so then you get more light the more filters you use, because you're repolarizing this light into this light. And if you only use 2 filters, then this light can't get through the second filter. But it can if you incrementally move it. Simple explanation, not complicated, provided dozens of times. So he says you cannot explain. That's the explanation. It doesn't matter whether the crystals used are pipping, tapping, or rat-a-tat. Oh, so it's the cowboy again. That tapping the results of the experiment is impossible without quantum mechanical explanation. So again, he's he's not. He's basically making a declaration that we know exactly what happens, and we know that our special crystal can detect photons, okay, without interfering with them, and that it creates maybe even these entangled photons. He has some special knowledge that that's what they are. They're entangled because he declares it so. You know, it's just a religion. All right, given that you spend so much time, so again, you're the one spending, it seems, an inordinate amount of time, you know, writing this garbage and watching my videos, and you're not making any counter arguments. You're saying somehow this convinces somebody. Who's it convincing? I mean, I'd like to take a poll of people. Is this a convincing counter argument? Did he provide some evidence here of something? No. So what is it? Nothing. All right. Given that you spend so much time on your other channel denying basic facts about feminism, genital mutilation. So again, he thinks that circumcision is mutilation. That is, it's some sort of deliberate, willful act to disfigure men, and that it doesn't have any sensible or rational function. And that he thinks that everybody who ever got circumcised by some kind of religious nut. That it wasn't just something done for what I think were perfectly rational reasons, and reasons that still exist as rational reasons. You know, it's healthier. Period. Just a fact. So, so again, this is his propaganda. So this is the kind of person you trust. Somebody who calls circumcision genital mutilation, as if it's, again, an act by the parents to make their son dysfunctional, to make him a monstrosity. That's what they're trying to do, which is just absolute nonsense. All right, the men's rights movement, like what men rights, the rights to be what, as retarded as you? So yeah, I mean, and I've pointed out how, yes, I'm a feminist, but the worst part of feminism is it seems a lot of women want to be as dumb as men. And that's the sad part of feminism. They want to be just as stupid and just as brutal and just as violent and just as smelly. And that's unfortunate. Among countless other things. Is it any surprise that you can't get a single detail correct? No, you're the person who can't get the details right. You can't get the evidence collected. You can't answer any of the questions I've posed when discussing your batshit insane science. So again, those are just your characterization, when clearly I pointed out that you're the ones who are insanely, fanatically devoted to this religious theory. And why are you? Because it has magic in it? Fairy godmothers? Little ratty-tatty fairy godmother? You need a fairy godmother? Is that why you want it to be true? Because you're a little pussy and you need a fairy godmother? Seems to me that's a reasonable answer. Or you're a child molester, of course. You are a complete joke. No, you're the joke, the troll joke. Okay, never providing a single answer. I mean, simple questions asked. Why didn't you post this comment on the simple questions videos where the simple questions are posed? Why don't you answer the simple questions? No, you're too big a fucking pussy. And it's time you give up on your Nobel Prize aspirations and move on with your pathetic existence. So again, I don't need to. My pathetic existence is rolling right along. I don't. It's the way it is. And again, in history, you're the one who's going to, like I said, I would ask, you know, just in posterity, if I'm already dead, that you go piss on this asshole's grave. Okay, that you have we put him in a grave somewhere where people can go and piss on it, because that's what he deserves. I mean, he's not making an argument. He's just a shit talker, a useless shit talker. Yeah, so piss on his grave as a deterrent to future assholes who do this, you know, naysaying, this pointless naysaying. No argument, just a naysay. No, you can't be right because I don't like you. It's that childish. He has nothing. He has no knowledge of the subject. He just trusts his little nerdy icons, and that's it. And you know, he'll attack anybody else. So it's like he's some He's like some Texan, probably a Texan. You know, he probably has one of those big spongy #1 fingers. You know, and that's how he thinks about how the world works, is that his team is the best somehow, and that it's worth throwing bottles at any other team that comes to play them because they're bad people. I mean, he's a fucking child. Okay. A psychotic child. So anyway, I will block him just because it is the cowboy. Troll account, troll account, troll account, troll account, and such. So anything else here that's not 500 years old, so fuck that. So no other comments, of course. So we'll move on with some other relevant bit. At 1449, summarized everything about his theory. Oh, well, I have to go look. This is like a really old video. So begins the revolution. This is like one of my first videos. It's like 6 years old. Let's see if the time code works, actually.
Yeah. The piece flies off of here and it hits some other electron somewhere else, and position has changed because it shoots it out at a different place because it moved in the time period of the transition. So as it's bouncing around, more time is absorbed, and therefore the position of electrons is changing, and therefore it will be reflected at a different time. And it's time that really changes that creates the illusion of reflection. It's the fact that time passed between the point it went in and the point it goes out, and in that time.
Right. So I'm just explaining how why things. I think this explanation just has to do with the reason why stuff slows down going through glass or something, is that its time is absorbed. And I'm basically pointing out how it's absorbed because the motion isn't a straight line anymore. It's a line dictated by the arrangement of the electrons, and they have to be. The force has to push the electrons, and the electrons can be in non-perfectly linear positions, that kind of thing. So, not a bad video for 4 years ago. So, just a useless comment, really. Yeah, quite useless. I have a more complete explanation. I mean, watching the 4-year-old videos, you know, it's your prerogative, but yeah, the newer ones are better. Draft Physics, name of the channel. So that's the idea is it's better with time. Idiot. Yeah. So anyway, so I guess we're done with that. So we could go to the Ken Wheeler video, or which is, you know, I can bring up a point about that, or I could play more of that stupid PBS thing. Let's see if there's any comments, which there probably aren't in the chat. Oh, Tyler. Oh, dear. Yeah. Is temperature the average kinetic energy of molecules? Well, I guess depends on how close your thermometer is to a particular set of molecules. You know, I mean, obviously you're measuring, yes, how many times little bits hit the thermometer. You know, that's what you're measuring. How many times the atoms in the fluid get hit by disturbance from the exterior world. You know, and that temperature has to be transmitted through the insulator of the glass, which, you know, isn't perfect, but the obviously the heat does finally get through the glass, even though it's a little resistant to the transfer of heat. Heat goes through glass fairly well. That is this movement, vibrations. So that's all you really have, is you have vibrations on the outside, then you have vibrations through the medium, and then vibrations get into the fluid. And, you know, so I don't know, your question seems so general that almost anything could be the right answer. All right, Tyler, I don't, you know, again, you really have to get your act together before you think you're a physicist. But anyway, Franklin on John Chappell kept mentioning the medium, which is pretty clearly defined in physics as a substance such as air that has an effect on force. I don't. You can. He's an etherist. Okay, you want to believe in ether? Go ahead. I don't care. I agree with him in that you are both right. Well, I don't know what that even means. If we're saying conflicting things, then I don't think we can both be right. So I'm just, I'm not really interested in personally tutoring you on physics. So you can either make an accusation or make a defense for a certain theory or a certain experiment, and I'll debunk it as best I can. But that's about all I'm interested in, really. So either provide some kind of argument with evidence, or this much doesn't really mean anything to me. But if you want to say two people are both right when they're saying different things, I'm saying that's kind of an idiotic thing to say, frankly. It's a waste of my time to sit there and do this. You're both right, even though you're saying opposite things. That just isn't very rational. All right, so there's one more. So does pressure cause those little bits to hit the thermometer? It's always pressure. Pressure's the whole game. Is the little bits are bouncing between the electrons, and there's little bits doing the same thing to protons. The whole thing is a pressurized system, and you're just conveying that pressure. So when you move the atom itself, you have to move it by absorbing pressure from a direction. So it has to be accelerated to move. And it's accelerated because more pressure on one side than there is on the other side, and it absorbs more of that pressure than, there's just more pressure. So there's more voltage, so to speak, pushing it one way than pushing it the other way. So it moves. And when it moves, it has a certain amount of mass. And then that mass, when the electrons from one atom meet the electrons from a new atom, there's going to be pressure between them. And so that's going to build up pressure as they get closer and closer. And as those electrons get closer and closer, the pressure they're creating between each other from the atom is going to be transferred into all the other electrons in the other atom, and connected to the other atoms, the same thing happens. So it's all just conveying pressure. You could argue it's all about conveying voltage, which sort of makes it an electric universe, but not in how the electric universe thinks it works. So does pressure cause the little bits to hit the thermometer? Yes. I'm trying to understand the relationship between pressure and temperature. Temperature is just a way of measuring a certain manifestation of pressure. You can have pressure in a system. Let's see how to say it. You can have a lot of pressure in the atom itself, but the pressure is equalized in the sense that the atom isn't moving anywhere. But it's like the Earth. The Earth has a lot of pressure in the center of its mass. You could say there's all this crust trying to get to the center, and it's pushing into the Earth. And so it's pushing all the matter. So there's a great deal of pressure, but it has no impact on the external world in a sense, all that pressure. It's not being conveyed because it's not in balance. And it's only when you imbalance the pressure, that is, you blow the Earth up or something, release the pressure, that all of a sudden you can realize it's the existence of it. So there's clearly a transition between the force, the ping pong balls, and the paddles. So I don't know how to explain it any other way, but I mean the paddles are the atoms. A collection of paddles is an atom. And the ping pong balls are the ones deciding where the paddles are position-wise. Let's see, how's another way of saying it? So I'm just saying temperature is just one way of measuring pressure that has been now manifested in the actual movement of things. So there was the same amount of pressure, you could argue, when the space shuttle sitting on the launching pad with a giant tank of oxygen and the hydrogen, and it's all the pressure's there. It's just not being released in a form that you could measure with a thermometer. Yeah, it's not in the form of atoms moving. It's in the form of the chemistry being more compressed. And later, when you ignite the rocket, you're expanding that chemistry. You're releasing the pressure. And now the atoms are moving. So it's just a different measurement, a way of measuring pressure. Temperature is one way to measure pressure. One way to measure the manifestation of pressure. One of the manifestations of pressure. One of the manifestations of pressure is the movement of atoms. That's where it's interesting. Heat is, in fact, voltage. Everything's, in fact, voltage, yes. I mean, everything that moves in a sense because of a conversion, a movement of a pressure. And the movement of pressure is essentially voltage. Voltage is the amount of the pressure. So the movement of more like amperage, but I'm just saying, yes, voltage has to do with the capacity. So the amount of pressure in a system. So it might not be pressure that can be realized because it's equalized. There's as much stuff going this way. So you have 100 volts going this way and you have 100 volts going that way. You don't have any volts. But you still have 100 this way and 100 that way. So you really have 200 volts, but you're not seeing it because it's not being released. So you got the song Pressure by, again, the women, you know, kind of not a very good, you're just being kind of cliche. That's where it's interesting. Okay, yeah, so you got the song Pressure by Paramore stuck in my head. Well, whatever. I don't care. It's not my fault. I mean, I'm sure every sentence anybody can utter might have a song title in it somewhere. And so, you know, whatever. So when it's in balance, they'd be potential energy, I guess. Yeah, I'm sure. I mean, there's a lot of potential energy in the compression of the Earth's core. So the Earth is compressing, the crust on the Earth is pushing in, creating pressure on the inside of the Earth, and that is essentially potential energy, yes. And when atoms are compressed, when more of their electrons are in the smaller orbit, a tighter configuration, so like they would be in normal positions would be this rim, and then, you know, when they're compressed, they're like an inch closer in. So they're the ping pong balls between the little electrons are bouncing more often and hitting more often because there's more pressure. So there's pressure capable of pushing them out again. So that's essentially the storage of energy. So when you pressurize a system like the Earth, when you push everything in, you're creating potential energy. But energy is a tricky word because it's, I suppose it's an adequate word because you just recognize that if you replace the word energy with the word pressure, you can get the idea that yes, you have to have some pressure to have anything happen. If there's no ping pong balls hitting, there's nothing happening. The paddles just stay where they are and nothing happens. The pressure is in the force. And if you balance your I'm trying to think of the way to say exposure the other way. If you balance how you impose the pressure, then you can store the pressure. Yeah, that's a pretty simple way to say it. All right, so an observation on the ferrocell, one of those guys that does the ferrocell videos that I've pointed to before. Anyway, he did one with a square ferrocell, and he only had lights on two sides. And it was kind of revealing because you only saw the pattern then on the two sides that weren't lit. So as I sort of speculated, the effect only happens perpendicular to the hitting the little bits of ferrite, the little bits of whatever is in the fluid, the ferrofluid bits. So the ferrofluid bits have kind of a shape. They're longer than they are wide, and they line up on the they line up as little magnets, okay, oriented based on the standard field lines. That's what they're trying to do. And it's only when you shine light this way, hitting them, that the light reflects and you see them. So the ones that are lined up this way and the light hits, they don't reflect. So any line going this way won't reflect any light. The light only gets reflected off the little bits if it's perpendicular to the arrangement of the bit. And so that's sort of a reveal in terms of, providing more information on how it works. Like I say, I have some ferrofluid. I really have to get around to playing with it. It still doesn't quite explain exactly why the lines are as curved as they are, because it really shouldn't be quite as curved. But clearly magnetic fields are curved, so some of that makes sense. But yeah, it's just really dissecting what you're really seeing. Let's see, what you're being fooled by. I mean, the device isn't it's abstraction. It has some distortion in what it's providing you as a description of reality. Just like these lenses distort. Like I said, if I put something close, too close, well, you can't really go too close with this kind of lens. But there's a place where, okay, it's just blue. The whole lens just fills up with blue. There's a place where, I can see the pen very well. It just changes depending on the distance. Because it has a point where you have to bend the light all the right way to get it to my eye. And so that's really important when the lens is backwards, because, yeah, you can still get an image, but something has to be very close to the lens for you to get the image. If it's far away, you have no hope of seeing anything that the lens is in line with. That's why it's important that it's the wrong shape. It won't focus a distant object. All right, that's a separate subject. So I guess we can just play some of this Ken Wheeler video and what the hell, unless you people have more comments or something useful. I don't know about like a polarized lens. I don't, there's no, lenses aren't polarized. It's just usually they're filters that are polarized. That has more to do with the polarization of the light coming off of an object and how the light got on the object. What the light, like sunlight reflecting, is glare, is always polarized. Yeah, it always has, anyway, so you can sort of filter it out and then see objects that were being obscured by the diffraction of the glare, by unfocusing them. Yeah. So when I got here, you were talking about an effect caused just by dirt on a lens. Now, just dirt on a piece of glass, a plain piece of glass, creates a kind of beam splitter. So as I pointed out, you put a plain piece of glass at a 45-degree angle, shoot a laser into it, and you'll get a lot of light, okay, bending this way and this way. So you'll have two beams. And when you do that, if there's dirt on the glass, what's going to happen is the light's going to get diverged by the rules of the single slit experiment, essentially. It's a bunch of little openings between a bunch of molecules. And so the light's going to get spread. And then that spreading means that it comes in at different angles inside the glass. And depending on how sharp those angles are, will decide how much it reflects inside of the two layers of the glass, the back surface and the front surface. And that's what's creating the ring pattern you see in interferometers. So the dirt is just an example of what the glue layer does in the cube style beam splitter, and it's a duplicate for what the what the half silvering does in the plain beam splitter, the half silvered kind that Michelson Morley used. Clearly, it creates a bunch of little openings, little apertures, and those little apertures diverge the light. By diverging the light reflects internally inside the glass. Anyway. So then he says, dirt on the lens. Was this the effect of the dielectric magnetic field? There's no dielectric anything except insulators can be a dielectric. A material substance can be a dielectric. There's no dielectric magnetic field. There's no dielectricity. None of those things are real things. It's all gibberish, nonsense. There's no rational theory defending any of the existence of this dielectricity kind of stuff. There's no dielectric magnetic field. No such thing. Oh, so it was about a wave particle experiment. No, it was about, I was reading a comment. I don't know if you can't follow along, but that's what I was clearly doing. I was reading a comment, and the comment brought a couple of subjects up. Whatever. Yeah, jeez. All right, so repeat this mush. Horrible mush. I probably have to reload it. YouTube will just keep doing this spinny thing. I have to turn the volume up.
Hello. We'll be making many videos over the next few days because one will be in Idaho and two just too busy packing and getting ready for the lecture.
So the lectures is excuse for not making videos, which it's just kind of a joke. But anyway, I mean, makes 6 videos a day.
Ooh, I twisted my back somehow.
It happens.
My digital fireplace keeping me warm. Specifically, I'll be talking about a lot of things in the lecture.
Yeah, it's good to have a $10,000 computer so you can have a screensaver on it all day. But whatever.
I only have 90 minutes. Of that, really, there's only 60 minutes for the lecture. The rest is a demonstration of the supercell, showing people how to make one, answering questions, and then...
Yes, well, it'd be interesting if he actually gets asked a decent question, like, how do you think the energy moves through this ferrocell to create the image? Whether he can even get the part right where, oh yeah, well, the light is perpendicular to the little bits of material, and so those only bits you see are the ones that get hit by light coming perpendicular to them. Yeah, something like that. Some explanation that this supercell isn't doing anything magical. It's not detecting some magical moving field. So again, they all rely on this idiotic notion that magnets have a bunch of energy in them, and there's a bunch of stuff moving and currents moving and all this stuff moving. There's no moving parts whatsoever. Magnets don't have any moving parts. All they do is filter. All they do is tell the red stuff to go right and the black stuff to go left. That's it.
Those are like a roundtable discussion of questions on Sunday with Eric Dollard, myself, and Aaron Murakami, which I didn't even know about.
Yeah, I saw another Dollard video. I don't know which one it was, but he was more wacky than he was in the other video I saw. So he says, what it says, Eric Dollard answers Facebook. He actually seemed kind of rational in that video. But this other one I saw, it was just all wooey nonsense. He's nuts. He's just completely nuts.
Until someone told me.
So he's going to this energy conference, and he hasn't watched any of their videos, doesn't know anything at all about them at all. He's just going because they're paying for him to go. And so it's just kind of funny, though. They had no curiosity. It's just a little bit of curiosity. You go to their website and you would know that they have a panel and that they all kind of present and try to sell stuff and do a lot of stuff. And he has no clue at all what this conference is about or what kind of people and what kind of presentations are made.
Humans have been playing around with lodestones now for thousands of years. We know that for certain, and using them as a medium for navigation, compass needles. But we have thousands of years of misconceptions. I have every book ever written on the topic of magnetism. The only
Again, kind of a silly statement to make, right? I mean, I think obviously I don't think he does have every book written on magnetism. That's just it just says it like it's, a reality when it isn't. But whatever.
dismal thing about modern science is it's never defined what a field is. A field is really simple. Of course, it's an ether perturbation.
Right, like that means something. So ether perturbation. So we'll write that down. Field equals ether perturbation. So jello vibration. Okay. And so the weird part of that is that the idea of the field is more that the stuff exists, that there is ether, not that it's necessarily being perturbated at the moment. So he's basically saying there's only a field when the field is being agitated by something, when something's moving through it. And again, the subject is that they have this perception that this ether field stuff somehow knows how to do straight line perturbations, ones that just go like a torpedo, like a bullet, and at the same time also do some kind of wavy perturbations, that somehow they know how to do a photon both ways. Sometimes the photon is waving, and then sometimes the photon is doing a torpedo thing through this field. It's not a field until it's moving. So it's a perturbation field. Huh? No, well, whatever. I mean, I obviously think the field is a good enough analogy, but the field is made of stuff that's moving. So it's always pressure in the field because the stuff in the field is always moving. The corn is always moving. So it's like a field of corn, but the corn always is vibrating back and forth and hitting each other. There's always pressure in the field.
Modalities of expression are no different than, a pathetic child thinking that water is one thing, ice is another, and steam yet another thing.
Yes, they are quite different things, so it's perfectly rational for somebody to make those distinctions. Why not? You make a distinction between a size 3 foot and a size 400 foot. Jolly Green Giant. Perfectly rational thing to do, make distinctions. They're different things. Notice the difference.
Well, of course, it's all water. They're just different modality expressions given.
They're rather dramatically just different. They're not a little bit different. They're very different. Okay, like liquid steel, molten steel is very different than, not molten steel. Very different thing.
And as in the case of fields, modality expressions relative to their source of genesis, but of course it would be
their source of genesis. So modality expressions, whatever that would mean. So these are, I don't know, how does it reveal itself? I guess that would be a modality expression. How does it make a happening? Yeah. And the origin of the happening he's going to get to somehow, but he'll never get to it. He'll never explain the origin of the happening.
Expression of pressure.
Now, see there, that's a good word, pressure, an expression of pressure. Very good. And so now we're just arguing about, well, what causes the pressure? And the argument is that you have to have the pressure from something. The Earth moves into the sun because something is really pushing it, not because it's not pressure, but because there is pressure, and you have to explain where the pressure came from. Just saying it's a perturbation doesn't work because there's no perturbator. So the pressure has to be in the field itself. The actual ether has to be made of pressure, or it can't work. It can't work as an explanation. That's why his explanation of magnetism fails, is because you have to explain where the energy comes from to move the two magnets into each other. And so it has to come from the field. It has to come from the outside. And he doesn't explain that. It can't come from the perturbator. It can't come from, it doesn't come from the magnet, quite obviously. The magnet doesn't lose any energy, so it couldn't have created the perturbation.
Case of fields, but in the case of water, of course, it would be temperature, obviously so, whether it be water, ice, or steam. But I mean, these are not different things. Human beings love to pigeonhole things.
Right. So related to the comment before, very good in a sense that, yes, temperature is basically pressure. So that would be an agreeable statement. If you would just stop there, we'd be doing okay. All right. So let's see what this. Oh, so it's about wave particle experiment. No, 1600. I don't know what that X. What does that mean? 1600X. Not very useful.
But specifically, there's no such thing as magnetic attraction.
So again, kind of a silly thing. And he also believes no such thing as magnetic repulsion. So, I mean, it's just a silly thing to say because we've defined the very idea of repulsion. It's almost connected to the idea of magnets and the fact that they, push back. It just doesn't make any sense to say there's no such thing as when it's a perfectly observable phenomenon. Now, defining what causes it, that's what we're trying to do, is what causes it. And so to say there's no such thing is just, it's insanely distracting. And it's just so dishonest to the truth. The truth is there is this phenomenon of two magnets moving towards each other. And somewhere the energy has to come from somewhere that's moving them. There's a cause for that effect. To say it doesn't exist and that it isn't appropriate to call it attraction would be idiotic. I mean, it's clearly, when you push two people into each other, I push somebody from behind into somebody else. Clearly, you don't say he was attracted to her. But clearly the idea of the two things coming together is fairly described as attraction. So I would agree. See, if he didn't also say there's no such thing as repulsion, then you could make this argument that, yes, semantically, it's probably wrong to say there's attraction because things don't move towards each other. They're not pulled, they're pushed. So there has to be an external pusher that pushes the things together. So the magnets move towards each other because the external pressure is greater than the internal pressure. Not a complex argument. So, but you'd still be stuck keeping one of them. There has to be either repulsion is real or attraction is real, but one of them at minimum has to be real.
Magnets do not accelerate towards one another. They actually accelerate towards a null point in the medium of itself.
A null point in the medium itself. And why would they accelerate towards a null point? So there's no explanation for why. So even if you could create this thing called a null point, why would the magnet accelerate towards null point? What does that mean to the magnet? Why do the atoms in the magnet say I must go this way? Why?
Between the two objects, magnets do not accelerate towards each other, nor is the acceleration you see.
Okay, so at least he's saying now they accelerate. So he's saying they don't accelerate towards each other, when clearly that's a reasonable thing to say, just because they obviously accelerate in the direction of each other. Now, they're not doing it because they love each other or any of these reasons. They're doing business being pushed into each other, but the idea is they're moving towards each other. So now he's saying, okay, let's separate the word accelerate from each other to just the accelerating. So now at least he's conceding they're accelerating. And let's see what he does with that concept. They're moving. Why did they move? See if he answers the question.
in any way, shape, or form due to magnetism.
So they're not moving because they're magnets, when clearly they only would do this thing if they are magnets. So again, how does this make any sense? How do people eat this crap? 163 likes, only 19 dislikes, and that's his crap answer. I mean, let's play it again. I mean, it's crap. This is mush. He's not saying anything.
You see, in any way, shape, or form due to magnetism.
So the acceleration doesn't have anything to do with the magnetism. I mean, how can you get away with saying something it's insane when we know it's only happening because of the magnetism?
Magnets don't have poles.
So another insane statement when we know they have distinctly different ends. That one end of the magnet's doing something very different from the other end of the magnet, and that you flip the magnets over, one of them, and those differences become obvious as inverses, and the magnet will function exactly the opposite. So turned one way, they strongly attract; turned the other way, they strongly repel. Clearly, they have poles. They're just idiotic to say they don't have poles, that they don't have fundamentally different properties at the two ends of the magnets. It's clearly different. Clearly plus and minus. Clearly black, white. Clearly different. Clearly polar. Opposite.
People think that magnets are emitting magnetism.
People think magnets are mini magnetism. Like, that doesn't make any sense. So I think what he was attempting to say is that people think magnets are made out of little magnets. Those would be the domains. And then still further down, the atoms themselves are little magnets. So the atoms line up, that creates a domain. The domains line up, that creates the magnet. So yes, it is little mini magnets. And when you break them, they always break on the same kind of jagged line, which leaves you with a north side and a south side. So they always break. All black ends, say this end up, they all break the same way as whole flashlights. Inside the atoms, the flashlights are arranged this way. So this is the north side, the red end, let's say, and this would be the black end. So those two are attracted. And so the next little bit would be lined up this way again, and then down here, and then this way, and then this way. So they're all attracted to each other. That's what holds it all together. And when it breaks into these, it breaks following the same rules.
Then a magnet is defined by its magnetism. Well, that's not true either.
Like, that even makes sense. A magnet is defined by its magnetism. Well, yeah, that's sort of how we identify a magnet. Strong magnet, weak magnet. Yeah, how many of the little atoms, how many little domains are lined up. Yes, that decides how magnetic it is. How much it expresses the property of being a magnet and a filter. How much filtering is it doing? To add my bit of clarification.
A magnet is far more so a dielectric object than it is.
So a dielectric object. It's nothing to do with being a dielectric anything. A dielectric is like a piece of glass or a substance that can hold charge on its surface, but it won't transmit charge from one side to the other. It's an insulator. So a dielectric is an insulator capable of holding charge on its surface. That's a dielectric. Magnets aren't dielectrics. Let's see what it says here. All right. Water volume to steam. So again, I don't know, 4 words, really doesn't say anything to me. 1600x water volume to steam. I don't know what that means. Is it only when they enter the same shared field space? There's no punctuation. There's not even a question mark on that. Clearly, it's a question, I would imagine, but I don't even know what to say about it. When what enters what field space? What are you talking about? But when they join, they are just one field. When what join? And act as if one magnet, correct? Yes. The whole point is it's a filter. So no matter how many of them you have, they just magnify the results of the filter. So the filter says random stuff comes in, black and red, let's say. And only the red comes out this end and the black comes out this end. So they're all doing that. Then you can sort of understand the more of them I have, the more black goes one way and the more red goes one way. That it can't help but magnify that process. And the process would be the same for the bottom of the magnet, right? So if the red thing goes into the bottom, it's going to come out the top. And if the black thing comes out into the bottom, it's going to reflect into the, the other thing. And the other thing is going to be red, which means it's going to go through the red. So everything's going to go, all the black's going to go one way and all the red's going to go the other way. And it's just the more little bits you have that are in the same arrangement, that means if you have turned one the wrong way, then it's going to be shooting reds the wrong way and blacks the wrong way. So it's going to be messing up your beautiful filtering. So it's just really about having them all lined up as close as possible to the same. And then that just means the more stuff, that means the more filtered. The more aligned up they are, the more energy is going to be filtered. The higher percentage of the energy will be filtered. So yes, the magnets are a magnify, yes, in a way, the filtering. And the center of that field would be the 0 point. Whatever is 0 point, center of the field, there's no center of the field, there's no 0 point between the two magnets that they move towards. And the center of the field would be the 0 point between the two magnets where they move toward. There's no 0 point between the magnets. There's just nothing to make sense out of that. It's like light bulb rays. The rays are coming off the magnets, the force. So it's all red coming off this end and all black coming off this end. And all you can do is neutralize that effect by having black ones shooting this way. And then you can have some point where it's a perfect mixture of red and black again. And that would be 0 magnetic significance because it's not polarized anymore. It's back to being mixed. The whole point is the force has impact because of the segregation. The segregation means it has an impact on electrons and protons because the red and the black affect the protons and the electrons in specific ways, opposite ways. But anyway, you have to watch my overview videos or the ones on magnetism to understand some of this stuff. I might not want to detail it in this freaking room. But anyway, there's the 0 point is just fluffy talk. There's no 0 points. It's just mush. The force doesn't interact with the force. Force has to reach the material body to affect it. The photons don't interact with photons. The stuff that is magnetism doesn't interact with magnetism. The bits, the photons have to hit something to release, convert their energy. They have to hit something material.
It's a magnetic one. We're doing lots of demonstrations, and I'll be confining myself to a lecture that I'm reading from to keep within the time parameters. I'm going to talk about magnetism endlessly until the cows come home. But then I'd go over, and then I wouldn't be able to hit on all the stuff I want to talk about. Here's a really...
all this stuff you want to talk about will be a bunch of jargon. And so it would be just jargon after jargon after jargon. And what will never be revealed is why the magnets move into each other and why the magnets move away from each other. What causes the atoms inside the magnetic material to accelerate, to move? That will not be explained.
Pertinent example is about the closest analogy you'll ever see on Earth of a black hole, but of course not a black hole. Compared to a typical magnet, you notice how huge.
So this is the ferrocell again. So as I pointed out, obviously, if you have a bunch of the ferrous material lined up around a ring magnet, especially, it's going to align with the field where the magnet is. So the magnet itself is going to be bright because it's going to be lots of material to reflect light. And so no light's going to be able to get to the center because the light's reflecting off the ferrous material that's under the magnet itself. And there's not going to be any in the center. It's all going to go where the magnet is. So a ring magnet is going to obviously give you a perfect circle in the middle because there's essentially no magnetism there. But hardly an analogy to a black hole. I mean, just a silly leap in nonsense. I mean, it's like I could just take anything that's round as a black hole. It's just like a black hole. It's just like a black hole. Just, I mean, it's a silly thing to do.
Huge the black hole is at the center of this really powerful N55 Gauss magnet. There's also a black ring around the edge. This is looking underneath the supercell of an N55 Gauss cylinder magnet, which is a 3/4 inch by half-inch thick. The reason why this
okay, sorry, it's just a round magnet, and again, the reason why the center is black is likely because the light doesn't get to it. There's no way for the light to get to the center.
Dielectric portal is so huge is that the more powerful magnet has far greater dielectric acceleration. The field, the magnetic field itself, is also palpably smaller, spatially smaller. And to say magnetism and to say create space and to
so he says all this stuff about how the magnetic field is spatially smaller and all this. We already know the rules that these magnets obey. So he's basically saying that no, magnets don't obey the inverse square law, that that these rules don't apply, when of course they do. So it's just kind of nonsense. The trick with magnets is you can dope them all kinds of strength. So there's no set rule about, you can have a tiny bit of the mass of the magnet at N70, and then the rest of the magnet could be N30, and some part of the magnet could be N10. So it's how much of the mass of the magnet has to be at the high Gauss reading. So it's just, it's just kind of silly though to say that, no, if I had a magnet that was well made and it was a N55, and I had another one was an N30, and they are the same quality. Of course, the N55 is going to have a larger field. It's not going to have a smaller field. It's just silly.
Say creates time. These are all one and the same thing. This is what the
yes, whatever. So the inside of magnets create time, which is just another. There's nothing complex about time. I'm just so sick of this time subject. People keep turning it into something. They make these idiotic arguments that because there's 3 physical dimensions, but if I want to meet somebody someplace, I have to argue you can't be in a place. You have to be at a place at a specific time. Therefore, time is like a place. When no, it's just a function. Time is just a function. It takes time for stuff to happen, and that's all it is. There's no dimension of time. It has no property that is at all like an up, a down, a right, a left, a forward, a back. It has nothing in common with the physical 3 dimensions. There's just no reason to call it a dimension. It has no dimensionality. It certainly doesn't have a Guess you could say it has a forward and a back. That would be like the left, right. See, the three dimensions have two subdimensions, two opposite, two poles. Past, present, you could argue could be the pole of time, but still, dimension is just a silly way to look at it.
By its force of motion. The extrinsic nature of the magnetodielectric conjugate geometry that defines what magnetism.
Okay, the magneto, blah, blah, conjugate geometry, blah, blah. And somehow this means something to people. Like I said, they thumb up this crap. Like they know I could give them a test and they could explain what the fuck he just said, what any of that crap was. I'm sorry, this is just so sickening. There's no way somebody's going to pass the Ken Wheeler test. If I just threw this jargon on pieces of paper and gave it to his fucking sycophant retards, they couldn't explain any of this shit. I mean, I just don't know why he gets away with it. Just jargon, just absolute bullshit. The magneto, blah, 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 blah. What does any of that mean?
Is and its relationship to the dielectric. These are like the inseparable.
So again, the dielectric, as if it's a thing, if something moving, when no, it's a quality that a substance has. It's not a thing moving.
Conjugate to twins. We say Siamese twins. We say conjoined twins. Doesn't matter what you call it. These are two and one and the same thing. We're just looking at water versus ice. So, well, here's water, here's ice. Human beings are fascinated with.
So ether is time or some kind of crap like that, when clearly you could argue that photons create a pretty good standard for time. I mean, that's sort of the definition of not instantaneous. So the fact that photons don't go from point A to point B instantaneously and it takes them time means that that's why we have time, is because the fastest thing we know of isn't instantaneous. So yes, everything has to be somewhat slower than that. So you need time now, because it'll take a certain amount of time to go different distances.
The ice, in case of magnetism, well, the dielectric is fundamentally the exact same thing, except the expression of loss of inertia manifests as this expanding and contracting circle.
Some expanding and contracting, this and that, but we don't see any of that in the real world. There's no, the little ferrous material doesn't expand and contract. There's no movement. There's no woo-woo crap going on here. This is just silly explanations. Silly. All right, still no relevant comments. So I'll do one more little bit. But this, it's not going anywhere. It's just jargon, 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 jargon.
It's not a two-dimensional circle. It's actually a force vector.
It's actually a force vector. Well, now he's talking like about something rational. So, but a force vector is at least two dimensions, maybe three.
It's not really a circle. The only reason we can call it a circle is because the interplay between the centrifugal divergent magnetism and the centripetal convergent dielectric, where the reintegrating magnetism.
I mean, like, we don't have a pretty standard definition of what a circle is. I mean, it's just like, come on, we know. I can tell the difference. Square, circle. I understand the difference. It's not really a circle. What do you mean? What else is it? It's a circle, idiot.
Back to the dielectric. They interplay the pressure mediations. Everywhere you see light is magnetism. Everywhere you don't see light is the dielectric.
So again, the dielectric is supposed to be doing the magnetism, and yet somehow it's not the doing part. So, where you see light is where the ferrous material is. That's the clear fact. So, there's no point. So anyway, probably enough. Fairly certain it's enough. Well, I don't want to be glued to a statement that I can't say for sure. Where you see light could be the oil between the oil between the ferrous material. So the ferrous material could actually be dark, and you're seeing the light but there's no reason for transition from the, really shouldn't be a transition. The light has to be coming off the ferrous material. It can't, it's reflecting off of it, and it moves through the oil layer to get to our eye. And what could be happening is it's also internal reflections in the glass again. So because you have the oil to glass layer, and so you have those refractions. So I have to think about that. But the point is it's perpendicular. That's one thing that has been figured out. The light only makes the pattern visible when it hits the ferrous material perpendicular to the ferrous material. So anyway, probably enough. It's like I said, it's all jargon, so there's no point in debunking jargon. And I see there's no other comments of any useful quality or substance. So apparently talking physics again has failed. People just don't have much physics to talk. So till the next time I feel like talking about it. I can only do my part, can't do your part for you. Although I probably could. I just probably should do that. I should just argue both positions. Maybe next time. I'll try that. And I won't need you people at all. Yeah, it's probably the solution. Anyway, till the next time and such.